Okay, so today we're going to talk about metric conversions. The last video we did was just dimensional analysis where we were doing conversions, but we were not doing it with metric units. Metric units are the units we want to use in science, and that is so whenever we are looking over someone's experiment that they did in Germany or that they did in Japan or that they did in any country, all of their numbers and their units are in metric units so that we all understand what they mean. Some people would have no idea what an inch was because inches are American standard units. Some people don't know what a foot would be. They have no idea what a yard would be. And in other countries, they have their own common types of measurements that they use. It's not that these aren't accurate. It's just that it's like a totally different language. So by putting everything in metric conversions, the language is the same. And in science, the international language of science in the written portion is always in English. So, and then in the math portion and the measurements in units is always metric. Okay, so it's very important that we understand how to convert metric units, and we have to know the scale. So we have base units. We've briefly discussed some of them, and our base units are just like a gram, and that's going to be when we're measuring mass. The base unit for volume is just going to be a liter. Okay, and for the mass, we would use a triple beam balance or an electronic scale. For volume, we could use a ruler and do the 3 dimensions, or we could use a graduated cylinder. So we got gram, liter, and then meter. Okay, so those are our 3 base units. When we convert, we can go left or right and move decimals to change from our base units to other units. So on the right-hand side of the scale, we have deci, which is a prefix. We have centi, and then we have milli. Okay, and so for example, you can have decigram, centigram, or milligram. Deciliter, centiliter, milliliter. Decimeter, centimeter, millimeter. Okay, so all of these use the base word, and then these are the prefixes. In the other direction, we have deca, and then we have hecto, and then we have kilo. All right, there are other ones on the other side like mega and micro. So mega would be here. So a megagram, and then over on the other side of milli would be a micro. Very tiny, okay, so tiny. So these would be hectograms, kilograms. This could be kilometers. This could be kiloliters. But these are all the prefixes. So I'm going to put a little dash in front of them. All right, so when we're moving digits, if we are going from, we are giving a decimeter, let's say 4 decimeters, okay, and they want me to figure out how many kilometers that is, then I'm going to move my decimal in the direction of the chart. I will move it to the left. So in the number 4, there is not a decimal written. So anytime a decimal is not present, it's always assumed to be right after that number. So if this was 500, the decimal would be assumed to be right there. Okay, so if I'm going from 4 decimeters to kilometers, my decimal is going to have to move just as many places as there are spots. So I'm going to have to go to the base, to the deca, to the hecto, to the kilo. All right, so I went from deci to the base, to the deca, to the hecto, to the kilo. And all those spots are held in place by zeros. So 4 decimeters is the same as 0.0004 kilometers. All right, because a kilometer is a whole lot bigger than a decimeter. If I had moved in the other direction, if I had started with 4, I'll do it in a different color, 4 kilometers, okay, once again, the decimal is assumed to be here, and I'm going from kilo to hecto, hecto to deca, deca to base, and base to deci, sorry. So that would fill in this way. So now 4 kilometers is the same thing as 40,000 decimeters. So depending on the direction you go, when we go this way, the number keeps getting bigger and bigger and bigger. When we go that way, it gets smaller and smaller and smaller. So using conversions, we're going to do a couple of questions. We're going to make sure we're able to convert correctly. So the first example would be 35 milliliters. All right, so that puts us starting here. All right, so we're at milliliter, and they want us to go to deciliter. So milli to deci, there is no zero here, no decimal, excuse me, so the decimal would be there. And we're going milli to centi, 1, centi to deci, 2. So we go 1, 2. Decimal sits right there. So now 35 milliliters is 0.35 deciliters. Another example. We'll do 0.005 kilograms equals how many milligrams? Okay, so we're going to start here at kilogram. Now this one has the decimal force, so that's nice. So we're going from kilogram all the way to milligram. So we're going to go kilo, hecto 1, to deca 2, to base 3, to deci 4, to centi 5, to milli 6. So it's going to go, I'll start it here. So it'll go 1, 2, 3, 4, 5, 6. So now the decimal is there, and that's a really weird looking number, but those zeros don't matter anymore. So 0.005 kilograms is 5,000 milligrams. So it's just a matter of converting. Where are you starting? Find your decimal and move left or right depending on the direction that you are going. So in the metric system, it's based on prefixes, and we just move back and forth depending on this pattern. Now, some people will teach you to memorize K, H, D, B, D, C, M. So that's kilo, hecto, deca, base, deci, centi, milli. And that's King Henry died by drinking chocolate milk. So the first thing you have to do is you have to make sure you can memorize the pattern. Once you memorize the pattern, you have to know if you can go back and forth. Some people will teach this process with steps. So they have kilo, hecto, deca, and then your base, which is gram, liter, or meter. And then you have deci, centi, and milli. And they just have you go up the steps, your decimal goes to the left, or down the steps, your decimal goes to the right. Okay, all of these processes work, but the main thing is you have to know the pattern and you have to know where a decimal is. So if I gave you 32.9, very easy starting spot because there's my decimal. So I can go that way or I can go that way depending on what I'm converting. But if I'm not given a decimal, then I have to know it starts at the very end of the number. Okay, so there's your quick little refresher on metric conversions, and now you're going to have a little online quiz with it, so you'll use this pattern and do your metric conversions.